Okay, hello everybody. I'm very excited to be here. Going to talk about passive house from natural materials. I do believe that it's not so complicated as you think it is. I think it's a fairly simple and a very necessary way to go forward with energy efficiency. And that's something maybe we talk very little about, but energy efficiency is a very important theme also for natural builders. First, we want to use materials that do not have a lot of embodied energy. But I have done some calculations, and most important, even more important than the embodied energy, is the energy you use over the lifetime of a building. And it's especially this energy which we try to save in a passive house. And it's savings which are not in the amount of 10%, 20%, 30%, but they are savings of 90%. You go to a 10% usage of what you do before. So, in 2006, we started with our first passive house. We had a customer who was very interested in this idea and gave us believe that we could do it, because that's always the first step you have to take. You have to have somebody who believes in you, and the first time you do something, it's always difficult. And we made it even double difficult, because we try to use as many natural materials as possible in the building. Here you can see from the inside, we also used clay bricks for giving more mass to the building, for better acoustics, and they were then later plastered. You can see the ventilation system which was built in. We had at that time, as you know well, there are two very important things you have to take care of, maybe three or four, but let's say the two important things you have to take care of in a passive house. First, it's a lot of insulation, that you have a lot of space for the insulation. Second, you need airtightness, which in this building we still used OSB boards which were taped off, so that we got an airtight building. This airtight building, I will come back to that, why this is so important. But as you see, we used also oak. It's non-treated oak on the outside. It will get silvery gray over time. Very nice, keeps 70 years. So probably much longer than the plastered pieces, which in fact are the plaster is put on wood fiber boards. And this was then the first passive house which is also certified in Slovakia. And the result, with the clay plasters inside, with the natural wood boards for the floor and oils and so on, was really an example which was very untypical for Slovakia. Here you can see some more pictures from the inside. The important thing to tell about this house is that after 2 years of measuring, this house with 170 square meters of floor surface uses 5,200 kilowatt hours a year. That's measured on the electro measure outside. So it takes into account everything: heating, hot water, and of course all the appliances you use inside the building. That's what I call energy efficiency, and we managed to get this done. Now we went one step further. What you see here is foam glass. It's recycled glass powder which has been treated with heat, made it very light. It's as I said, a recycled material which is then brought into the foundations, compressed, about 30% compression. We put layers of up to 0.5 meter after compression of this. There is no capillarity there is no water coming through. And on top of that, we make a concrete slab. There is no more necessary to dig the foundations down to 1.20 meters to non-freezing areas, because the foam glass, which you can see here coming out nearly a meter from the foundation, is insulating the earth from below, or from the cold coming down. So in fact, the earth underneath the slab will never freeze. The slab is kind of floating on this foam glass, which also has very good insulation values of lambda of 0.08. And with this, we get details which do not have any thermal bridges. And with this, we went one step further. We made now these foundations, and on these foundations, we started to build houses with massive wood panels, with cellulose fiber insulation, wood fiber boards, which are again plastered on the bottom part, and the wood facade on the top. So in fact, most of them are all about natural materials on this. The interesting thing about this house, which is in the north of Slovakia, is what the investor sent me in January, a mail that said, now the sun is shining every day. I have not heated in the house for 4 days, and outside I have temperature of -4 during the day and -15 at night. I'm walking around with my t-shirt at 26 degrees inside. That's the mail you are having a lot of pleasure to listen to or see when a customer is so satisfied with his building. And it shows that good insulations, airtightness, and the right windows, which you will also see, is a very important ingredient to produce a quality house. This house is the only one, as you can see, it's the only one which has a chimney at the moment. Usually we don't put chimneys in passive house because it doesn't make much sense. But he wanted to make his heating only by an oven. Now, this is a mass oven with about 2.5 kilowatts of output. He heats twice a day with about 7 kilo of wood. When it's really cold outside, that means -15. Otherwise, when it's around 0 or -5, sometimes only one time 7 to 8 kilos of wood is enough to heat the whole house. So it's very little work. It works fantastically. The heat dissipates in the whole building. It really goes to all rooms, because when you have a very well insulated building, the heat will go quicker through the inner walls to dissipate into the whole structure than being lost to the outside. So you can have just one heat source and it will work well. That's the advantage of a passive house. I told him that one room will probably be corner room will be a little bit colder, where he's going to have his office. But he has a computer there and 2 monitors. So when he turns them on, he heats that room as well. So it works really very, very well, and he gets the extra 2 or 3 degrees in that room just by turning on the monitors, and that's the comfort when you're sitting. To get this right, of course, a chimney needs to be airtight built in. So as you can see, we put the chimney to the outside, if possible, directly, so there is as little as possible of the chimney inside. And we put a stainless steel plate around so that we could then connect it up through the wooden element. And on the other side, on the outside, this is from the inside. Here is insulation going in. On the outside, we have this foil, which we then taped it to. So we get an airtight connection. And we did the blower door test, like we do in all our buildings, where we measured 0.09. It's 0.6 is the maximum value for a passive house, we really got a fantastic value, which is far below what we really needed. This airtightness is very important. It's enough to, if you just have to think about one thing. If you want to heat your living room with 30 candles, that's the reality. You don't need a lot of wind going through your construction to take that heat out. So airtightness is very important, and I know that a lot of self-builders who do a lot of construction with straw bales have a lot of problems heating their houses in wintertime. It's not because they are badly insulated. Straw bales insulate well, but because when the wind comes, it will just blow through the